When the door of imagination opens, a vast, waiting expanse comes into view. The universe stretches out like an endless black tapestry, where distant specks of light pulse quietly to the ancient rhythm of its own breath. Tonight, the journey begins in the stillest of moments, where the mind drifts freely across a sea of stars, listening for the strange stories the cosmos has kept since the dawn of time. In this hush, each tiny shard of light becomes a subtle sign that ahead lies a voyage into some of the most mysterious anomalies humankind has ever known. As imagination wanders farther from Earth's familiar orbit, an image appears, like the opening scene from a cosmic fairy tale. It is a planet covered in a sea of glowing red magma, where the ground splits open and endless rivers of molten rock pour forth like unending streams of fire. On that surface, the light that rises is not meant to guide the way, but to gently remind us that some worlds are born in flames, grow through ferocity, and stand unshaken in the cold emptiness between stars. Everything seems foreign, and yet it carries a beauty that defies explanation, a form of life that needs no breath, no gentle shades of green to exist. Farther still emerges the image of a colossal star, so immense that its very presence bends the space around it. This star does not simply shine. It is slowly consuming the planets that orbit too close, drawing them into its blazing arms. Orbits once steady now twist into desperate spirals before sinking into the star's boiling, furious surface. No sound accompanies the scene, only a sweeping sense of awe at the realization that the universe is never still. It shifts, it erupts, it renews itself endlessly through cycles humans can only quietly witness. Each time this vision returns to mind, the sheer grandeur of the cosmos brushes gently against one's thoughts, leaving behind a soft mist of wonder and humility. Then the darkness expands, wider than anything the imagination can comfortably hold. It is not the darkness of an earthly night, but the primordial black of deep space, where light itself seems swallowed by an invisible silence. There, the universe's future appears, a distant time when the stars will fade one by one, leaving their final embers sinking into an eternal shroud. This darkness does not breed fear. Instead, it feels like a reminder that every cycle has an ending, and that even the universe is slowly making its way toward its own long and quiet sleep. Throughout this journey, cosmic anomalies do not emerge as bizarre oddities, but as distinct chapters in an ancient book, where each page reveals a new secret. From molten worlds to planet-devouring giants, from the depths of shadow to the smallest fragments of light, everything is woven into a single, continuous story. No detail stands alone. Every phenomenon is a note in the silent symphony of the universe. And as the journey continues quietly, a feeling forms, like drifting along a river of soft thoughts. The universe is not merely a place filled with numbers, formulas, or physical laws. It is a story of birth and disappearance, of radiant moments and profound darkness. Every step beyond Earth lets humanity see its own smallness more clearly, yet also feel cradled by this vastness, as though space itself is gently holding all unanswered questions. These images make the mind lighter, slower, and somehow deeper in its sense of floating among the galaxies. The exploration of cosmic anomalies is not an invitation to fear or unease, but to appreciate the wonder of existence. Whether it is the swirling lava of an ultra-hot planet or the infinite dark where no star remains, each scene reveals a kind of beauty unknown anywhere on Earth. Against this immense backdrop, Every detail appears like a gentle invitation. Planets turn slowly around strange stars. Giant suns tremble with each burning breath. Deep voids hold only a handful of lonely sparks. All of it flows like a quiet current, guiding the mind away from the closeness of the everyday world. And the farther one drifts, the larger the sense of peace becomes. Like the universe is using its vastness to soothe the lingering thoughts of a long day. The most wondrous thing is that even though these phenomena are powerful beyond imagination, they never stir tension. They exist so quietly, the way the universe itself drifts through billions of years without haste. When you think about these anomalies in that slow rhythm, it feels as though you're sitting inside a grand library, where every cosmic event is an open book, telling its story through light, heat, time, and silence. And so the opening chapter comes to a weightless close. The journey has begun not with an explosion or blinding light, but with a gentle drift into the depths of space. A place where every strange phenomenon waits to be understood, every distant world waits to be discovered, and every quiet interval waits to be heard. The universe extends its doorway wide, not urging, not insisting, just softly inviting with the vast and mysterious beauty of its own existence. As the opening chapter of the journey settles into quiet, the images of fiery worlds, planet-devouring stars, and deep, silent darkness continue to drift softly across the mind. In that stillness, a question slowly rises. If the universe is so vast, where might we find a place that carries even the faintest echo of Earth? And from that question, a key is revealed, a guide to a special scale created to search for familiarity among countless cosmic anomalies. That scale is called the Earth Similarity Index, or ESI. It is a delicate measurement ranging from 0 to 1, built to assess how closely distant exoplanets resemble Earth. On this scale, Earth holds the value of 1.0, serving as the standard against which every discovered world is compared. Each planet, whether large or small, scorching hot or bitterly cold, can be evaluated through factors like size, density, surface temperature, and broader conditions tied to the possibility of supporting life. When we look at this spectrum of values, it feels as though humanity can rearrange the chaos of the universe into an orderly map, where numbers quietly narrate how close or far these worlds are from our blue home. On that map, some planets stand out with impressively high ESI scores, sometimes reaching 0.8 or even 0.9. Those numbers carry a fragile whisper of hope, as though somewhere out there, a world might exist that is gentle enough, familiar enough, Earth-like enough to cradle life. Such planets are of moderate size, not so large that they become gas giants, and not so small that they lose their atmosphere. Their surface temperatures occasionally fall within a mild range, not cold enough to freeze everything, yet not hot enough to make life impossible. When these worlds are mentioned, it feels a bit like gazing at distant reflections of our own home. Yet most of the universe is not that gentle. Many exoplanets hold very low ESI scores, sometimes just 0.1 or even close to 0. These numbers are not rejections. They are mirrors reflecting the immense diversity of space. They may represent worlds scorched so intensely that rock melts into flowing rivers, or planets so cold their surfaces resemble mirrors of eternal ice untouched by starlight. Some places exceed every concept of size, while others are so tiny they cannot hold even a thin veil of atmosphere. Each low-scoring planet carries its own story, a story of conditions so extreme that life as we know it struggles to take root. Yet within that harshness lies a new perspective on the universe, reminding us that not everything must look familiar to be fascinating. As one observes the range from 0 to 1, the ESI becomes more than a tool. It becomes a quiet reminder of Earth's special place. Among the vast ocean of planets, Earth is like a rare island, holding a balance so strangely perfect that it feels almost improbable. Gentle sunlight from the sun, an atmosphere neither too thick nor too thin, liquid water across its surface, all combine into a fragile but harmonious whole. When placed upon the universe's scale of numbers, Earth's uniqueness emerges not only biologically, but mathematically, physically, and even philosophically. For this reason, in the journey to explore cosmic anomalies, understanding the ESI feels like planting one's first foot onto solid ground before stepping into the wide open sky. This scale helps humanity recognize familiarity within the unfamiliar, like a small lantern flickering at the end of a hallway with no visible end. Yet at the same time, it reminds us that the universe does not contain only Earth-like worlds. It weaves countless scenes that defy every boundary of imagination. Those worlds, even with low similarity scores, are often where the most astonishing stories wait to unfold. And as the ESI fades gently into thought, a feeling as light as cosmic wind slips into the mind, that the path ahead will no longer revolve solely around familiar places or comforting patterns. Instead, it will stretch into stranger, deeper landscapes, places where numbers no longer describe habitability, but instead open doors to wonders that cannot be measured. It is an invitation to step beyond the edges of the known, into realms of shadow, of light, of fire, of ice, everything the universe quietly stores away. From this moment on, the journey will drift farther from worlds that resemble Earth and move toward the rare extremes of the galaxy. From planets circling pulsar stars to lands where lava sprawls like endless seas of flame. From shadows that swallow all light to marvels where two suns rise together. Each destination will be another note in the universe's mysterious symphony. And the ESI, now completed in thought, becomes the final marker of familiar ground before the voyage enters a deeper, wider, and more enchanting part of the stellar expanse. As the story of the Earth Similarity Index comes to a gentle close, the images of familiar worlds slowly fade, like a green island disappearing behind a veil of cosmic mist. From that soft boundary, our journey begins to drift away from the safe haven of tranquil planets and into a far more extreme realm, one where the very existence of a world is already a paradox. Far beyond the landscapes, we know lie the remnants of stars that have died, yet have not completely gone dark. These are neutron stars, the dense cores left behind after a massive star explodes in a supernova. A mass nearly equal to that of the Sun is squeezed into a sphere no larger than a city, creating an almost unimaginable density. When these remnants spin rapidly and emit beams of radiation from their poles, we call them pulsars. These strange lighthouses rotate endlessly, sweeping their beams across space and leaving behind rhythmic pulses that telescopes can capture like the steady ticking of a cosmic clock. Many pulsars spin incredibly fast, some turning dozens or even hundreds of times each second, sending their beams flashing through space with exquisite regularity. And by measuring these repeating pulses, humanity detected tiny wobbles, subtle shifts that revealed something tugging on the star, planets orbiting around it. It was these faint little wobbles that led to a historic discovery. The first confirmed planets outside the solar system weren't circling a young, vibrant star. They were orbiting a pulsar named PSR B.57 plus 2. It was a paradoxical beginning to the story of exoplanets. While humanity dreamed of finding second Earths, the universe offered its first answer in the form of worlds orbiting a cosmic grim reaper, where the light shining on them was not warm or life-giving, but the leftover heartbeat of an explosion long past. The environment around a pulsar is a mosaic of extremes. Gravity is so intense that all matter is compressed, and any orbit must follow precise, curved paths. High-energy radiation beams sweep across space, unleashing invisible storms of particles onto any planet caught within their reach. These worlds are not bathed in the steady golden glow that warms Earth, but instead receive flickering, distant pulses, cold, sparse, and irregular. If you were to stand on the surface of such a planet and look up, you might see only a single point of light blinking rhythmically in the void, like a lone clock hanging in the darkness. Planets around pulsars may be cold, barren rocks, once wrapped in oceans and atmospheres that have long since been stripped away, leaving behind only a hardened core resilient enough to withstand relentless radiation. Their temperatures may be extremely low or vary with their orbital distance. Under constant showers of X-rays and gamma rays, the organic molecules familiar to us would struggle to survive for long. On the ESI scale, these worlds would almost certainly rank extremely low, near the extreme opposite end of Earth's gentle habitability. And yet, it is precisely their existence around a pulsar that makes them so captivating. After the parent star explodes, shock waves and radiation should erase nearly everything around it. And still, over time, matter finds a way to gather, to settle, to form planets that quietly continue orbiting this extreme remnant. Some planets may even have survived the explosion itself, distorted, shaken, pushed into new orbits, but not destroyed, eventually stabilizing around the star that has become a pulsar. No matter which scenario is true, these planets tell the same story. In a universe where decay and chaos seem inevitable, there are still structures that choose endurance, spinning steadily without complaint. The strange contradiction of these planetary systems is this: they orbit a cosmic harbinger of death, yet they display remarkable balance and persistence. A pulsar, an emblem of a star's demise, becomes the anchor for long-lasting orbits. And the planets, which should have been torn apart, instead remain like stubborn stones dancing around a flickering ember, refusing to let go of their paths. Familiar life may have no place in this picture, yet the beauty of endurance, the steady revolutions, the rhythmic pulses remains. Soft as a slow melody, the universe whispers to itself. And as the images of these lonely pulsar worlds gently dissolve back into the infinite darkness, the journey prepares to shift once more, toward a different kind of world, where the surface is no longer frozen rock, but vast oceans of boiling lava. From the orbit of a frantic remnant, the next step will bring the imagination closer to planets glowing red-hot, where the ground melts into rivers of fire under the too close gaze of their radiant stars. As the image of planets turning within the harsh radiation fields of pulsars slowly dissolves like a thin veil of mist in space, a faint sense of the fragility of every orbit lingers gently in the mind. And from that very fragility, the journey drifts onward toward another extreme realm, one where light is not just a distant flicker, but a flame that burns an entire world bare. Within this vast cosmic tapestry, there are planets not wrapped in the cold darkness that surrounds worlds orbiting pulsars, but instead heated so intensely that their surfaces melt. They lie so close to their parent stars that not a single moment escapes the scorch of relentless fire. Among them, one world stands out. 55 Cancri A, often referred to by a simple yet haunting name, the lava planet. This world is larger than Earth, belonging to the class of super-Earths, yet its position is far too close to its star. That proximity sends daytime surface temperatures soaring to thousands of degrees Celsius, hot enough to turn any kind of rock into glowing liquid. On the day side of the planet, oceans of molten lava spread out like a vast, simmering sea, shifting slowly under their own gravity, forming quiet, fiery waves. When imagining it, one might picture a world where red is not just the color at your feet, but the very hue that stretches out toward the horizon, merging seamlessly with the light of its parent star. The sky on such a world is neither the clear blue of Earth nor the deep black of wandering planets. Instead, the air above the surface may be clouded with vaporized rock, tiny particles rising and dissolving in unbearable heat. In some theoretical models, scientists even propose the possibility of strange rainfall, showers of molten stone where droplets of liquid rock evaporate upward from the lava seas, cool ever so slightly, then fall back down onto the glowing surface below. Everything moves slowly, heavily, as if the entire planet is beating to a thick, heated pulse. Viewed from afar, 55 Cancri A might appear like a red gem holding a flame within. Light reflecting off its molten surface gives it a brilliant glow, standing in stark contrast against the darkness wrapped around it. There are no signs of softness here, no room for water, no gentle atmosphere. Every element is overwhelmed by heat and the crushing nearness of its star. It is a world poised in a delicate balance between existence and dissolution. If one were to float at a comfortable distance, gazing at this lava planet, the first feeling might be a kind of awe at the sheer heat radiating outward, even if only imagined. The orange-red light rising from its surface softens every contour, as though the planet were a breathing sea of fire. And yet, when watched long enough, that intensity becomes something almost serene. A slow, steady motion, like a broad ribbon of energy expanding without urgency. In its absolute ferocity lies a strangely gentle rhythm, offering a sense that is both alien and familiar, as if witnessing the deep, deliberate heartbeat of a molten world. 55. Cancri A is not the only lava planet in the universe, but it is one of the most striking examples of a world burned down to its core. Its existence raises questions about the many forms a planet can take, and about the astonishing variety of pressures the cosmos can impose upon matter. While Earth is wrapped in oceans, sheltered under a balanced atmosphere, and warmed by the right amount of sunlight, a lava world faces extremities so severe that no biological structure seems likely to form. Yet those very extremes make it a milestone in our exploration, for it reveals how far beyond our familiar standards the universe is willing to reach. Reflecting on a lava planet reminds us that harshness is not the opposite of beauty. It is simply another expression of it. The beauty of burning light, of ceaseless motion, of matter caught in a constant cycle of melting and solidifying to the rhythm of temperature and orbit. Such a world is like a blazing page in the universe's journal, telling a story not meant for life, but for the boundless imagination of humankind. And it is precisely at this edge of imagination that a gentle shift begins to unfold. From the red-hot oceans of 55 Cancri A, the journey prepares to wander toward a cold, shadowed realm elsewhere in space. For beyond these worlds melted by starlight, the universe reserves places that drift with no star at all, planets wandering alone in eternal night. In this stark contrast, the cosmos opens a new chapter, guiding the journey into an icy stillness where solitude becomes the very essence of an entire world. As the glowing red seas of 55 Cancri fade behind a hazy veil of distance, the planet's ferocious heat seems to dissolve into quiet waves of memory. And from the very edge of that burning intensity, the journey slips into a realm of complete contrast, where warmth is stripped away, leaving only absolute cold embracing an utterly solitary world. In this moment of transition, from fire to frost, from radiant crimson to eternal darkness, the universe reveals another form of planetary existence, worlds that belong to no star at all. These are the wanderers of space, the so-called rogue planets, drifting aimlessly through the deepest, most silent reaches of the galaxy. A rogue planet is a world cast out of its original orbit, or one that never had a parent star to begin with. With no sunlight to guide them, no fixed path to obey, they drift without direction through the interstellar night. They may be large or small, rocky or gaseous, but they all share one defining trait: absolute solitude. Each rogue planet is an island torn away from every center, floating through silence with no beginning and no destination. The surfaces of these worlds lie wrapped in near-perfect darkness. There is no day, no night, only an unbroken landscape of infinite black. The only illumination comes from distant stars, so faint they are almost meaningless. At times, a pale cosmic ray may brush across the frozen ground, highlighting it for the briefest instant, and then the darkness folds back in as though it were never disturbed. Temperatures on rogue planets often plunge to levels close to the chill of interstellar space itself. Any atmosphere, if one exists, may freeze into a thin crust. Water, if present, could become solid ice that refuses to melt for billions of years. Even solid materials grow brittle, stiff, as though they are sleeping beneath the cold blanket the universe has laid atop them. Yet this cold is not hostile. It feels more like a deep stillness, a long pause in the life of matter, where every motion slows, every echo is swallowed. If one imagines standing on the surface of a rogue planet, perhaps the first sensation would be absolute quiet, so profound that one might almost hear the sound of their own existence. In the sky above, no sun ever rises. There is only an eternal night dotted by a sparse scattering of distant stars. These stars remain still, unchanging, barely flickering, faint stitches upon a perfect black tapestry. There is no dawn, no dusk, no shifting palette of reds fading into purple before melting into night. Time itself becomes flat, as though each second stretches into an entire age. The solitude of a rogue planet is not a threat, but a kind of serene stillness. Here, there is no brutal radiation from pulsars, no surging oceans of fire like those on lava worlds. There is only a planet held in peaceful cold, where all grand movements disappear, leaving behind only a slow drift through endless space. Some theoretical models suggest that beneath the thick ice of certain rogue planets, heat from the core might linger, preserving a fragile pocket of warmth. In the infinite dark, that slight heat could form underground oceans where matter still moves, still collides, still continues its quiet chemical story. This opens the possibility that even in the loneliest places, faint sparks of life, primitive, secluded, might still find a way. But whether or not these hidden oceans exist, the beauty of a rogue planet lies in its stark contrast to starlit worlds. If lava planets are explosions of energy, rogue planets are the stillness where energy settles. One world roars with heat, the other sighs with frost. Each represents a different verse in the universe's silent symphony, none opposing the other, all simply different notes on the same cosmic scale. Seen from afar, a rogue planet might resemble a drifting black gemstone suspended in the sky. No reflections, no sharp outline, just a dark silhouette gliding slowly across an even darker backdrop. Alone, yet unhurried, it continues its path, neither wavering nor rushing, never stopping. In this imagined observation, a sense of stillness spreads outward, seeping gently into every thought. The rogue planet feels as though it's inviting the listener into its inner quiet, a space where time relaxes and the echoes of life soften. Here, every disturbance of the universe comes to a halt at the threshold of absolute darkness. And as that enveloping calm becomes the foundation for whatever comes next, the journey prepares once more to shift. For beyond this world abandoned to eternal night, the universe holds yet another extreme. Planets so black they swallow light itself, darker than coal, dimmer than the shadow of nothingness. From the deep cold of rogue planets, the next step will carry the journey toward these cosmic charcoals, where light becomes a lost traveler before vanishing completely. As the image of those wandering planets fades into the endless darkness of space, their quiet solitude lingers like a thin, chilly mist around the thoughts they leave behind. And from that mist, the journey drifts deeper into the night of the universe, into a place where darkness is not just the absence of light, but a presence of its own, something that seems almost aware of how to swallow every stray beam that dares to pass through. In that distant depth lies one of the strangest worlds astronomers have ever found. It is known as one of the darkest planets ever discovered. This is TRES-2b, a gas giant roughly the size of Jupiter, yet cloaked in a shade of black so complete it feels unreal. Its reflectivity is shockingly low. Less than 1% of the light that touches it ever escapes back into space. The rest is absorbed almost entirely, as though the planet were made of material designed to imprison light itself. TRES-2b circles a star in the constellation Draco, not so far that its star cannot reach it, but close enough for its atmosphere to heat to thousands of degrees. Yet despite such intense temperatures, the planet doesn't glow brightly like other hot worlds. Instead, it emits only a faint, reddish haze, barely detectable, like the weak breath of a massive furnace smoldering quietly in the dark. There are many theories suggesting that the atmosphere of TRES-2b contains special compounds that devour light with extraordinary efficiency. Elements like sodium, potassium, or tiny carbon particles resembling soot. These substances cause any light that touches the atmosphere to vanish, as if falling into a bottomless abyss. Even the powerful light of its own star can only coax out a deep, dim red, like the dying ember of a coal slipping into silence. Seen from afar, TRES-2b looks unlike any familiar planet. It does not glimmer. It does not shine. It does not carve a bright outline against the dark. Instead, it appears as a drifting patch of black, slowly moving across the sky, like the shadow of an invisible object blocking the light behind it. Its presence is defined not by color or contour, but by the very absence of light it carries. Looking at it feels like observing a living void, a cosmic charcoal gliding quietly through the galaxy. Though it is a gas planet, with no solid surface to imagine standing on, its atmosphere is made of towering layers of hot gas, slowly swirling under the pull of heat and gravity. Yet, imagining oneself floating nearby does not bring to mind storms or chaos. Instead, there is a strange calm. Darkness has a way of smoothing motion, of making every violent swirl appear distant, muted by a thick, silent veil. When light from the parent star passes through the planet's atmosphere, it does not scatter into the vibrant patterns found on worlds rich with diverse molecules. Instead, it is absorbed, pulling the planet deeper into absolute shadow. The curves of its atmosphere only emerge in a faint, murky red glow, like a quiet reminder that beneath the calm darkness lies a massive reservoir of heat, churning invisibly. TRES-2b becomes a symbol of the paradoxical nature of the cosmos. A planet blazing with furnace-like heat wears the appearance of the deepest night. A world so close to its star that its atmosphere is driven into thousands of degrees still refuses to reflect almost any light at all, like a black flame burning alone. This contrast makes it mesmerizing, as if it is not merely a planet in the universe, but a fragment of darkness pulled free from the cosmos itself. From a scientific perspective, TRES-2b is a testament to the limitless diversity of gas giants. But from the perspective of imagination, it embodies the essence of absolute night. Thinking of it feels like watching a nocturnal phantom, not supernatural, but planetary, a shadow that moves, gathers light, and leaves behind only silence. If a rogue planet carries the feeling of solitude, TRES-2b carries the feeling of uncertainty, a soft haze of something unknowable. It does not wander without purpose. It orbits its star with precision. Yet this connection does not make it brighter. Instead, it adds depth to the darkness traveling with it, as though star and planet are performing a slow cosmic waltz, one partner radiant, the other holding tightly to perfect black. When imagining this planet in a moment of peaceful reflection, time seems to stretch, as if its rotation is blending into the velvet layers of night surrounding it. TRES-2b is not a warning nor a threat. It is simply a reminder that light and darkness do not exist to oppose each other. They create a profound balance woven throughout the universe, a balance to which every planet, every star, and every drifting particle contributes in its own small way. And as the darkness of TRES-2b gently closes like a soft curtain in the mind, the journey prepares to open the next chapter. For beyond this realm of perfect shadow, there are worlds lit not by one sun, but by two, planets with twin stars glowing together, warming a shared sky. From this cosmic charcoal that devours all light, the next step leads to the double-sunned worlds, where day and night take on entirely different tones, and the heavens hold two bright beacons resting side by side in the quiet of space. As the silent shadow of TRES-2b drifts into the distant reaches of space, the feeling of having just passed the deepest edge of cosmic night lingers softly in the mind. Yet right where that darkness dissolves into fine specks of faint light, the journey opens onto another slice of the universe, one where light is not swallowed, but doubled into a rare, dreamlike spectacle. In another corner of the sky, there are planets born between two suns, turning within the shared presence of twin starlight. One of the most famous of these is Kepler-16b, a world that instantly evokes memories of Tatooine from stories of distant galaxies, not because of shape or life, but because of the breathtaking sight of two suns shining in the same sky. Kepler-16b is not a world of vibrant colors or menacing mysteries. Its charm lies in the quiet elegance of its dual orbit. Two stars circle each other, and this planet circles them both, creating a slow, graceful dance of light, shadow, and time. When morning begins on this world, the horizon does not brighten from a single direction. 2 points of light appear, sometimes slightly offset, sometimes merging into one streak of warm brilliance. In the moment when both suns rise together, the sky becomes a canvas dyed with unfamiliar colors. Pale gold spreads from one side, deep orange from the other, blending into hues that do not exist on Earth. No morning looks the same, for the distance and alignment of the twin stars shift continuously with each cycle. Imagining oneself standing on a quiet field of Kepler-16b, the first sensation would be the gentleness of twin sunlight. The glow from two stars does not double the intensity. Instead, it stretches into a soft, shared illumination, spread so evenly that no place feels overly bright. Shadows on the ground also tell a curious story, for a single object may cast two silhouettes, moving slowly with the turning of the sky. And if morning is a painting of interwoven light, then sunset here becomes an entirely different chapter of poetry. When one sun sinks below the horizon, the other remains, coloring the sky with deep purples and tender reds. When both finally descend, darkness arrives not in a single fade, but like two streams of light withdrawing one after the other, leaving behind layers of color as smooth as drifting silk. A day on this planet does not end with one sunset, but with two, each one gently pulling away a portion of the day's glow. It feels like watching the day conclude twice, each ending a variation of quiet beauty. Kepler-16b is not ideal for life as Earth knows it. It may be cold, its atmosphere unstable, its chemistry unwelcoming, but none of this diminishes its beauty. For this world's appeal lies not in habitability, but in the spectacle of light it is granted. In a universe full of chaos and extremes, not many places offer the chance to see two suns sharing the same sky. This world exists like a peaceful pause amid all the extremes the journey has crossed. Standing still and looking upward in imagination, one might sense the delicate balance between the two stars, one a smaller orange sun, the other larger and brighter. Both cast their colors across the land, fading gently as time stretches on. The wind may be cold, the soil barren, but the sky remains radiant in its own unmistakable way. The very existence of a two-sun world is a reminder of how the universe often holds truths that human imagination once reserved only for fiction. For decades, the image of a planet with twin suns belonged solely to movies. But telescopes later proved that the universe has always been larger than the scripts we write for it. The orbit of Kepler-16b is surprisingly stable, circling the dual star system with steady precision. It is remarkable when one considers the influence of two powerful gravitational bodies. Yet nature always finds a way to craft delicate equilibrium. The planet is not torn apart, not flung into distant space, nor pulled into one of the stars. It maintains a safe, harmonious distance, just right to keep both suns within sight. Imagining once more that distant field, bathed in gentle light from both sides, the world feels like a cosmic fairy tale. A place where simply standing under the sky is enough to make the journey feel renewed. A world where days last longer, light is more abundant, and yet the quiet remains as soothing as on planets with only a single sun. And as the image of the twin suns slowly shrinks into two faint dots in the expanse of imagination, the journey begins to turn once again to a place where light is no longer soft or delicate, but blazing and overwhelming. For beyond the peaceful glow of Kepler-16b, the universe prepares to unveil a star so enormous that ordinary intuition cannot contain it. A red supergiant named Stephenson 218, where every notion of size becomes small beside its immense presence. As the image of Kepler-16b's twin suns gently fades from the imagination, the soft hues of the day still hover, like a thin ribbon of cloud that has not yet dissolved into night. And right at the boundary, where that paired light begins to disappear, the journey turns toward another kind of radiance, larger, deeper, reaching far beyond any notion of brilliance humanity has ever known. In that distant stretch of sky lies a star whose size defies intuition. Stephenson 218, a colossal red supergiant often regarded as one of the largest stars ever observed. Its greatness is not merely poetic. It is so vast that familiar measurements shrink in comparison, as though every number were just a modest attempt to name an immensity that refuses to be contained. If Stephenson 2-18 were placed at the center of our solar system, its edge would stretch all the way to Saturn's orbit, which means that our Sun, though considered the grand torch sustaining life on Earth, would appear only as a small glimmer within an enormous sea of fire beside Stephenson 2-18. Its radius is about 2,000 times that of the Sun, and its volume could hold trillions upon trillions of Earths and still have room to spare. The physical world that Stephenson 2-18 creates is one where everything unfolds on a deliberately slow scale. Its surface is not a crisp sphere, but a blurred, deep red expanse, mottled like drifting clouds that dissolve and gather again. Nothing on its surface stands still. Matter drifts in hot, lazy currents, moving like vapor within a flame, light yet profound, soft yet charged with energy. Together, these motions evoke the sense of a star that breathes, a rhythm so vast it seems to stretch time with every swell and collapse. Around Stephenson 2-18, space is tinted by a faint red glow that spreads across millions of miles. This is not the sharp brightness of searing blue stars, but a gentle light that diffuses like a mist. Every grain of dust, every drifting stream of material is wrapped in this red shimmer, creating the illusion of an ocean of luminous fog where edges blur and everything melts into a quiet warmth. Imagining a close approach to such a star brings not overwhelming shock, but a wide and spacious calm. Despite its unbelievable size, Stephenson 2-18 does not conjure destruction in the mind. It carries the solemn presence of something that has lived a very long time, burned through immense stores of fuel, and now rests in the final chapter of its stellar life. It feels like a gentle giant aware that its most radiant days have passed, offering only a last, lingering warmth before fading into the dark. In the stillness around it, one can picture layers of hot gas moving slowly, like silent waves gliding across its surface. No region of this star is truly stable. Everything shifts continuously, light and slow, as though the star itself were drifting through its own contemplations. The mottled, dark patches on its surface become traces of deep internal changes, where matter shifts density and temperature over cycles far longer than any rhythm known to humankind. Stephenson 2-18 stands as a symbol of the universe's ungraspable vastness. If planets with two suns offer the poetic beauty of twin lights, then this red supergiant offers the awe that arises from pure existence. It is proof that the cosmos can exceed every ordinary notion of size, and in that excess lies an unexpected peace. For when confronted with something so immense, we cease to measure and simply feel. Yet Stephenson 2-18 is not immortal. Like all red supergiants, it will eventually reach its end, concluding its life in a magnificent supernova. In that moment, its material will be cast into space, weaving new clouds of gas and dust, sowing the seeds of future stars. Its story, then, is not only one of greatness, but of the cyclical birth of the elements that form both the universe and life itself. But in this imagined present, while Stephenson 2-18 still glows, Its entire presence exudes a tenderness difficult to name. Though overwhelmingly large, the star radiates a slow, gentle rhythm, like a long exhale drawing the universe a little closer. Each glimmer, each drifting plume of gas carries with it a sense of peace, as though the star wishes to threaten nothing, only to be witnessed before sinking into darkness. As the imagination drifts away from this giant, its pale red glow lingers like the last streak of daylight. And from that fading light, the journey prepares to move toward another kind of star. One not enormous in size, but burning with a heat so intense it cannot be approached. For after the vast, unhurried presence of Stephenson 2-18, the universe is ready to unveil a vision of the most powerful blue flame in the galaxy, where temperature rises beyond every limit humanity has ever known. As the gentle red glow of Stephenson 2-18 slowly recedes behind you, the echo of its vastness lingers in the mind like a faint morning mist that clings to the air after a long day. And as that pale red haze gradually dissolves, the sky opens into a different kind of brightness. Not the deep, quiet crimson of before, but a fierce blue-white brilliance, as though the universe is revealing another flame, hotter and purer than anything seen until now. That flame bears the name WR102, a Wolf-Rayet star belonging to the class of some of the hottest stars ever observed in our galaxy. Its surface temperature reaches around 200,000 Kelvin, tens of times hotter than the Sun, an intensity so extreme that familiar concepts of heat begin to lose their meaning. 102 is not merely hot. It is the embodiment of thermal energy pushed nearly to the extreme of stellar combustion, a realm where nuclear reactions burn so violently that they hurl matter outward in powerful stellar winds. Wolf-Rayet stars are those that have nearly exhausted the hydrogen in their cores and have begun releasing layers rich in helium, carbon, oxygen, and heavier elements. Their spectra no longer show hydrogen like youthful stars, but instead carry the signatures of deep internal burning. They are living relics of stellar evolution, powerful, delicate, and poised at the edge of their final stage. WR102 is a vivid example of this intensity. Imagining it from afar, one sees a blazing blue-white torch burning fiercely in the dark expanse of space. Its light does not diffuse gently like that of a giant red star, but shoots outward, sharp, bright, and strong, like streams of molten steel. The incredible heat forces surrounding material outward at tremendous speeds, sending out stellar winds that sweep billions upon billions of particles into space every second. Yet within the unhurried rhythm of this imagined journey, WR102 does not appear threatening. Instead, it feels like a great flame viewed from a safe distance. Its intensity softens when placed against the slow drift of space. Even its brilliant blue-white glow, bright enough to light up the regions around it, carries a kind of purity, as though the star is burning with everything it has left to prepare for a magnificent ending, likely a future supernova. If a planet were unlucky enough to orbit near WR102, it would not endure for long. The star's heat would strip away atmospheres, burn through solid matter, and leave behind only drifting ashes carried outward into space. But in this journey, survival is not the focus. What matters is the image of pure combustion, a testament to how nature behaves at the edge of physical endurance. To imagine a star like WR102 is to feel the stark contrast between it and Stephenson 2-18. If Stephenson 2-18 is slow, vast grandeur, a silent red ocean adrift in the dark, then WR102 is condensed intensity, a beam of light piercing through shadow. One star stretches its presence through size. The other ignites its existence through sheer heat. And strangely, within that fierce energy is a kind of rhythm. The stellar winds flow outward steadily, like strong, controlled breaths. Layers of hot gas are pushed away in waves, forming ripples of light that expand slowly outward. Everything unfolds at a consistent pace, unhurried, as if the star knows that this burning is the last chapter of its life and wishes to complete it with clarity and purpose. Wolf-Rayet stars like WR102 are the sources of many of the heavy elements in the universe. When they explode, they scatter into space the atoms that will form new generations of stars, new planets, and even the foundations of life. WR102, then, is not just an ending flame. It is a cradle for countless stories yet to come. Imagining WR102 from a distance is like watching a brilliant blue torch standing alone in a cosmic desert at night. The space around it appears darker, deeper, making its blue-white blaze stand out even more. Its light is not gentle like the twin sunsets of a two-sun world, nor quiet like the darkness of TAR-AS 2b, but the fierce radiance of burning pushed beyond ordinary limits. And as the mind slowly drifts away from this torch, it feels as though the blue-white shimmer still clings to thought, a faint streak left in one corner of the imagination. A reminder that the universe is vast, not only in size but in intensity, in energy, and in the personality of every star. As WR102 shrinks into the distance, the journey opens again toward another destination, one where power does not come from light, but from sheer mass. For after witnessing the hottest blue flame in the galaxy, the next step leads toward a star that needs no heat to command the universe's respect. A star so heavy that it exceeds every familiar limit of gravity and endurance. As the image of WR102 slowly fades into the pale blue-white expanse, its fierce flame lingers in the mind like a dying ember that has yet to cool. And just as that light retreats into a single dot in the great canvas of the cosmos, the journey opens once more, this time toward a different kind of star, one that does not burn with extreme heat alone, but with a mass so enormous that it stretches every familiar notion of gravity. Deep within the star cluster R136, nestled inside the Tarantula Nebula of the Large Magellanic Cloud, lies a star so massive that the very idea of gravitational balance seems strained beneath its weight. That star is called R136A1, often regarded as one of the heaviest stars ever known in the universe. If WR102 is a brilliant blue torch, then R136A1 is a blue stellar behemoth, where mass, light, and energy converge into a forceful, yet deeply fragile existence. R136A1 is not as large in size as Stephenson 218. It does not swell to thousands of times the Sun's radius. And yet, what turns it into a true monster is its overwhelming mass, about 200 times that of the Sun, a number that pushes every familiar law of stellar physics to its limits. With such mass, its core is pressed to unimaginable pressures and temperatures, driving nuclear fusion at a staggering, relentless pace. The surface of R136A1 is incredibly hot, so hot that the light it emits shines in a brilliant blue-white blaze. Its luminosity exceeds the Sun's by more than 1,000,000 times, bathing everything nearby in a radiance almost impossible to picture. Out in the vastness of space, this star appears like a blazing blue gem, constantly pushing matter outward with fierce stellar winds. But its enormous mass condemns R136A1 to a brief life. Through the time scale of stars, the lifespan of such a colossal titan is barely a blink. It burns through its fuel in a furious rush, like a flame consuming itself with all its strength in the shortest possible time, only to head straight toward an inevitable end. a dazzling supernova explosion, perhaps one that leaves behind a heavy black hole. Imagining oneself standing at a distance, R136A1 might appear as a cold yet powerful light, a field of blue energy stretching across the surrounding space. It is not soft like the faint red glow of Stephenson 218, nor sharp like the blue-white gleam of WR102. Its light is something in between, a strange blend of brilliance and pride, intensity and transience. In stars this massive and blue, every process unfolds faster, stronger, more violently. Elements in the core are forged at speeds far beyond those of ordinary stars, while radiation constantly strips away the outer layers. Any planets, if such a thing could exist nearby, would struggle to keep their orbit or even retain their structure under the assault of light and stellar wind. Existence around R136A1 is nearly impossible unless one is far beyond its reach. Yet in this journey, R136A1 does not appear as a symbol of destruction, but as a radiant moment in the life cycle of stars. It is a brief summit, a high note in the long symphony of the universe. It lives fast, burns bright, and disappears, leaving behind fragments of matter that will become the foundation of generations of stars to come. Its colossal mass also raises profound questions about the limits of star formation. How could a cloud of gas gather into a star this heavy? How could nature forge an object whose mass should have caused it to collapse long before it ever shone? The answers are not yet clear, but the existence of R136A1 proves that the universe always finds creative ways to exceed human expectations. In the imagination, R136A1 does not stand still. It seems to tremble softly with the streams of energy rising from its core. The light around it shifts constantly, uneven yet smooth, like the heartbeat of an enormous being burning with the power of hundreds of suns. And within those tremors lies a gentle sadness, the sadness of stars that live too quickly, too fiercely, only to vanish too soon. That fleeting nature gives R136A1 a strange beauty. Despite its monstrous mass, it does not feel threatening in this journey. Instead, it evokes a quiet, reflective mood, as if telling a brief but brilliant story, then smiling softly at the thought that its ending will scatter the seeds of the universe's future. As the image of this heaviest star slowly fades into the void, a faint, lingering feeling remains, like the soft echo of a musical note fading away. And from that fading echo, the journey prepares to move into a new chapter, where the remnants of stars, the condensed hearts of the cosmos, await their turn to be told. For after these massive monsters comes the story of neutron stars and magnetars, where gravity, magnetic fields, and density reach the deepest limits of physics. As the strong blue light of R136A1 slowly drifts away, the sense of impermanence carried by those massive stellar giants lingers like a thin wave in the mind. And from that radiant yet fleeting echo, the journey gently shifts into another realm, one where the power of stars no longer lies in their brightness or mass, but in a form of matter condensed to its ultimate limit. When a massive star ends its life in a supernova, its outer layers are blown outward into space, leaving behind a core compressed to an almost incomprehensible degree. That core becomes a neutron star, one of the strangest objects the universe has ever created. Though only the size of a city, roughly 20 to 30 kilometers across, it carries a mass comparable to the Sun. This means that a single spoonful of neutron star material would weigh billions of tons. Its density surpasses every physical experience humans have ever known, brushing against the very boundary of matter's existence. Neutron stars do not burn fiercely like R136A1 or WR102. They do not shine with colossal light or expel mighty stellar winds. They simply spin extremely fast, like the remaining heartbeat of a dead star. Each rotation lasts only milliseconds, producing steady pulses of light across space. When those pulses reach Earth, we call them pulsars, the steady lighthouses of the cosmos. But among neutron stars, there exists a group even stranger, more intense, and more enigmatic: Magnetars. Magnetars possess magnetic fields so powerful they defy imagination, trillions of times stronger than Earth's. Such force can distort the structure of matter, twist atoms, and unleash violent upheavals so intense that even a tiny shift on a magnetar's surface can release gamma-ray storms across space. In the imagination, a magnetar might appear as a small, dark sphere, occasionally flickering with a faint, blue-violet glow, like a halo escaping from a storm compressed into silence. Each flash is brief, barely more than a blink, as though signaling from a world balancing itself between primordial forces. These colors are not the radiant light of giant stars, but deep, thin, sharp strokes, the marks of energy pushed to its limit. Magnetars do not rotate lazily. Some spin incredibly fast, completing a rotation in mere milliseconds. As they turn, their magnetic fields sweep through space, leaving invisible disturbances that affect particles and waves across vast distances. All of this unfolds in absolute silence. No blasts, no shrieks, only the signs of extreme energy trapped within a tiny sphere. Their existence is proof that the universe can push matter into forms no one ever imagined possible. If neutron stars already stretch the limits of imagination, then magnetars go further still, making magnetism the dominant force. They do not shine widely or glow softly, but their power commands respect from everything surrounding them. And yet, within this gentle, sleep-guided journey, the magnetar does not appear as a threat. Instead, it feels like a quiet heart still beating, slowly, deeply, in the universe's darkness. Each blue-violet flicker is like a heartbeat, a sign that within that small sphere, an ancient form of energy continues to live. Not loud, not demanding, just a silent, sovereign presence. Neutron stars are often described as the remnants of massive stars, the hardened cores left behind after their outer layers have drifted into space. They are like condensed memories of the universe, recording the final phases of stellar evolution. If R136A1 and WR102 are the blazing, exuberant chapters, then neutron stars and magnetars are the slow, contemplative pages that follow, the story of what remains after the burning ends. One can imagine observing a magnetar from afar, a small sphere floating in perfect darkness. No warm red glow like Stephenson 218, no radiant blue blaze like WR102, only a dense blackness, occasionally torn open by a razor-thin flash of violet-blue light. These flashes are faint, brief, and silent, yet they create the feeling of looking directly into the heart of nature's most primal forces. If the earlier parts of the journey revealed the diversity of stars during their lives, then neutron stars and magnetars tell the story of death. Not a death of ending, but a death that transforms into new forms of existence. These stellar remnants can merge, creating gravitational waves, or collapse further into black holes if their mass grows. Each ending opens into another possibility, like musical notes sliding gently into one another in a galactic symphony. And as the imagination slowly pulls away from these ultra-dense spheres, a soft sense of reverence remains, as though the universe has just whispered a secret it has kept for ages. and from the quiet pulse of the magnetar, the journey prepares to turn to the next chapter, where the death of matter is no longer simply compression, but becomes a bottomless abyss, where light cannot escape and space-time is bent into wondrous shapes. For beyond these stellar remnants lies the story of black holes, where every familiar rule is challenged. As the image of neutron stars and magnetars quietly turning in the dark drifts away, the sensation of their extreme density lingers, like a soft, hidden pulse echoing through the silence of the universe. And from that faint rhythm, the journey begins sliding into an even deeper region of space, where matter is not only compressed, but bent to the final limits of existence. A black hole is one of the strangest anomalies the universe has ever formed. It is not an empty hole, not a pit or a doorway into nothingness, but a mass compressed so brutally that all familiar descriptions fail. Its density becomes so high that light, the fastest thing in the universe, cannot escape its gravity. The very existence of black holes proves that space and time are not rigid. They can be stretched and distorted like soft fabric. There are many types of black holes, but the most astonishing are the supermassive ones that sit at the centers of galaxies. The most famous example is the black hole in the galaxy M87, an object once photographed directly, holding a mass about 6 billion times that of the Sun. Or the quasar TON 618, one of the heaviest black holes ever inferred, with a mass reaching tens of billions of suns. Imagining billions of suns compressed into a region small enough to fit within a few planetary orbits makes gravity, mass, and distance feel like fragile illusions. Black holes do not shine. Their centers, the event horizons, are regions where light cannot escape, forming an absolute darkness. But what surrounds them is entirely different. As matter spirals inward, it whirls around the center at immense speeds, heating from friction until it glows with incredible radiance, forming an accretion disk brighter than many stars. This disk looks like a luminous ring encircling a deep shadow, a contrast so intense it seems impossible, yet appears naturally in the hidden corners of the cosmos. In a slow, quiet imagining, a black hole appears as an invisible well, with light bending around it like ribbons of fabric caught in the pull of something unseen. This bending warps the space around it into the shape of a distorted mirror, stretching the stars behind it into bright arcs. All of it happens in perfect silence, for in the vacuum of space, even the most violent events make no sound. Standing before a black hole, of course only in the safe realm of imagination, the feeling is not fear, but reverence, a being born of stellar death, yet existing as pure gravity. No light, no sound, only presence. Its silence is so profound that even thought seems to slow near it. Black holes do not chase objects like in stories. They simply sit, unmoving, letting gravity do the rest. If a star, planet, or cloud ventures too close, the pull will draw them into a spiraling orbit, tightening until they fall into darkness. But from a safe distance, black holes are harmless, just heavy stones drifting quietly through space. Everything depends on distance, simple principle inside a profoundly complex entity. In supermassive black holes, the accretion disk can shine so intensely that it becomes the core of a quasar, the brightest lighthouses in the universe. From billions of light years away, their glow can still reach Earth after crossing unfathomable expanses. This makes black holes a stunning paradox. The centers themselves are dark beyond imagining, yet the regions around them can be the brightest phenomena we have ever observed. Imagining a black hole is like gazing into a bottomless abyss, not an abyss of rock or earth, but of space itself. A place where time slows, where light bends, where physics feels less like laws and more like metaphors. And yet, a black hole carries an almost meditative stillness. It feels like a pause in the flow of space-time, a boundary where motion ceases once the invisible line is crossed. If one continues to observe, the majesty of the black hole becomes clear. Not a majesty of size, but of nature. It does not need light to show its presence. It does not need motion to show its strength. It simply exists, and that alone is enough to bend space around it. Within this sleep-guided journey, the black hole does not appear to threaten, but to remind, to speak of the universe's depth and quiet. An absolute abyss, yet an absolute stillness. A stillness not empty, but meaningful, like a rest note in the long symphony of the cosmos, necessary, balancing, and profoundly solitary. As the imagination slowly drifts away from the black hole, its shadow lingers like the deepest mark of the journey so far. And from that perfect darkness, the path begins to open into another spectacle. A place where light is not swallowed, but thrown across the cosmos with such force that distant galaxies become lanterns in the cosmic night. For after black holes comes the chapter of quasars, the brilliant beacons at the universe's edge. As the absolute darkness of the cosmic black hole slowly closes behind you in the vast silence of space, the feeling of a lightless abyss lingers, leaving a deep imprint in the mind. And from that very center of darkness, the journey opens unexpectedly into a scene so opposite, so dazzling, that it feels almost unreal. A place where light is unleashed with the greatest intensity known in the universe, bright enough to cross billions of light years and still arrive radiant. A quasar, an ancient cosmic beacon, is one of those brilliant lighthouses perched at the edge of what we can observe, where the most distant galaxies reveal their fiercely burning hearts. At the core of every quasar lies a supermassive black hole, billions of times heavier than the sun, devouring matter at a terrifying rate. As matter falls inward, it is crushed, heated, and whipped into a spiraling storm, glowing brighter than hundreds of thousands of galaxies combined. This light is not ordinary. It is one of the most extreme forms of energy the universe can produce, as matter plunges into an endless gravitational well. Across billions of light years, a quasar appears as a solitary point of brilliance in the darkness between galaxies. But once you realize that this point shines 1 trillion times brighter than the sun, its scale and power overwhelm any intuitive sense of proportion. A quasar is not merely a glowing dot. It is a luminous echo from a much younger universe, a time when everything was louder, hotter, and far more energetic than it is now. If you imagine looking directly at a quasar, you might picture 2 blazing jets shooting from its poles, like giant cosmic spotlights sweeping across space. These streams of matter are accelerated to nearly the speed of light, flung outward by magnetic fields and the immense energies of the accretion disk. They don't just shine. They pierce through the dark, as if the universe were drawing lines of pure light across an infinite night. In this strange contrast, a quasar becomes extreme light born from absolute darkness. A black hole itself cannot shine, yet the very process of shredding matter around it creates the brightest phenomenon ever known. That contradiction makes the quasar a beautifully paradoxical symbol of the cosmos. From a place that should be silent and invisible emerges light that outshines everything. To observe a quasar is not simply to see a distant object. It is to look backward in time, because the light reaching us today began its journey billions of years ago. Each quasar is a doorway to the early universe, a window into a period when galaxies were young, turbulent, and overflowing with energy. To see a quasar is to witness a moment in cosmic history when chaos still held the upper hand. Despite their terrifying power, quasars are unimaginably distant, far too far to influence anything near Earth. Their light reaches our eyes not because they are close, but because they blaze with such intensity that they illuminate the vast emptiness between galaxies. In this sleepy journey, a quasar becomes a gentle lantern burning in the endless night, not a threat, but a guide for the imagination. Picture yourself watching a quasar from some far-off vantage point in space, seeing a steady point of light against an infinite black backdrop. It doesn't flicker like a star. It holds steady, radiant, deep, like a flame kept alive by the immense gravity of the black hole itself. And if you stare long enough, you might sense a soft kind of breathing, not biological, but the quiet, rhythmic glow of matter falling endlessly into an accretion disk. Each quasar is a testament to the power born from the interplay of matter and space-time. It reveals the complexity of the fundamental forces when stretched to the largest scales. And while its appearance is brilliantly radiant, its center remains a dark hollow that cannot be seen. This contrast makes the quasar unforgettable, reminding us that in the universe, light and shadow often coexist in ways we never expect. Quasars also mark nearly the outer limit of what humanity can observe. The brightest ones are the most distant objects ever detected through telescopes. Their light has traveled billions of lonely years, crossing empty cosmic deserts before finally reaching human eyes, like a message sent from an age long vanished. And because a quasar is among the most powerful phenomena in existence, it naturally becomes the brilliant peak of our journey through cosmic light. After a quasar, every other glow feels softer. Every movement feels slower. Every chaotic swirl in the universe seems to settle, like the surface of a lake after a passing storm. As that overwhelming light slowly fades into the distance, wonder lingers, but the emotional surface begins to smooth, as though the universe itself gently lays a hand upon your thoughts to calm them. And just as the quasar's glow melts back into the dark fabric of deep space, the journey prepares to drift into a quieter realm, one without piercing beams or furious energy, only the vast, tranquil emptiness of cosmic voids, so immense that everything before this moment becomes just tiny points of light in memory, as the extreme light of a quasar slowly shrinks into a faint glimmer, like the last ember sinking into the cosmic horizon. Its radiance lingers in the mind, glowing softly like a fading memory. And just as that light dissolves into the dark, the journey begins to drift toward its complete opposite. A place without brightness, without noise, without any clear motion. Only an expanse of emptiness so wide that every notion of distance feels suddenly small. The universe is not only made of blazing quasars or wild, roaring stars. It also holds regions that contain almost nothing at all, vast cosmic voids. Among them, the Boötes void stands as one of the most striking examples. It is a hollow stretching nearly 300 million light-years across, so large that even if tens of thousands of galaxies were placed inside it, the space would still feel empty. The Boötes void is like an enormous rest in the cosmic symphony, a place where everything falls away into silence. If you imagine standing in the middle of the Boötes void, the first feeling may not be fear, but a soft kind of displacement, like drifting through an infinite, perfectly quiet sea. There is no radiant quasar blazing nearby, no crowd of stars painting bright patterns across the sky. All around lies a dense darkness, softened only by the faint glow of a few lonely galaxies at the distant edge. Tiny sparks trying to hold their place in an endless night. This emptiness is not true nothingness, but it is so sparse that anything within it feels small. If the rest of the universe resembles a sky embroidered with countless starlit stitches, a void is the untouched fabric between them. A wide, cold, silent stretch, like a breath held for a very long time. Within the Boötes void, only a handful of galaxies are scattered about, each separated by tens of millions of light years. The distances are so vast that if one galaxy sent out a single beam of light to greet another, that beam could wander for millions of years before ever arriving. It makes the Boötes void one of the loneliest regions humanity has ever discovered. Imagine looking around and seeing darkness extending without end. No bright point to anchor your gaze, no nearby stars to form a familiar sky. Each galaxy, enormous in its own right, becomes just a tiny, isolated spark in a sea of space. And within that loneliness lies a strange beauty, one shaped by absolute simplicity, where nothing competes for your attention. The Boötes void is not an accident of nature. It formed from the way matter spreads through the universe, where galaxies gather into walls and superclusters, leaving vast emptiness between them. The cosmos is like a giant web. The bright strands are where matter collects, while the broad dark spaces are the undyed cloth between the threads. Seen from afar, the voids resemble gigantic bubbles woven through the structure of the universe, nestled between glowing clusters of galaxies. They are not dense, nor do they shine, yet they are essential to the cosmic design, shaping how matter is distributed. In a metaphorical sense, voids are like the rests between musical notes, not meaningless gaps, but the pauses that give the symphony its balance. If you were to stand in the Boötes void, you might feel an absolute quiet settle over everything. No wind, no sound, no sign of nearby motion. Space seems to stop flowing, and time feels slower, softer, more distant, as if you were gently dissolving into the velvet darkness of the universe. This silence is not frightening. It is like a tender lullaby, inviting the mind to loosen and drift. The contrast between the brilliant quasar before and this void now reveals the universe's remarkable diversity. One place erupts with extreme light, where energy reaches its highest limits. The other is a vast emptiness where light is too weak to truly touch anything. One dazzles beyond comprehension. The other is so subdued it almost seems unreal, and yet both are essential pieces of the same grand picture. The Boötes void is particularly striking because of its scale. Even traveling at the speed of light, crossing this void would take hundreds of millions of years. Its immensity makes it not just large, but a symbol of cosmic solitude. Not the loneliness of a single being, but the loneliness of space itself on a universal scale where distance becomes a kind of essence. In this emptiness, a gentle softness begins to unfurl. Nothing struggles, nothing collides, nothing stirs, only an infinite hush, like a dark blanket laid across a vast stretch of space. The longer you look, the softer the emptiness becomes, and the loneliness turns into a deep, soothing calm. The Boötes void feels like a slow breath of the universe, a quiet expansion, a long pause before the movement continues. In that moment of stillness, you might forget all the grand motions of the cosmos, because nothing here recalls brightness or chaos. It recalls only stillness. And from this stillness, the journey prepares to turn to a new chapter, one where the universe is no longer serene as a silent lake, but begins to widen, cool, and stretch farther than ever. For beyond the voids lies the story of cosmic expansion, where space keeps growing and the distant future becomes an endless dark ocean, leading gently toward the quiet, contemplative ending of the journey. As the boundless stillness of the Boötes void slowly drifts into the deeper layers of darkness, the feeling of an endless emptiness lingers in the mind like a thin veil of mist. And from that vast quietude, the journey begins to flow toward an even wider vision, one where not just a region of space expands, but the entire universe gently stretches outward like a long and unending breath. The universe does not stand still. From the moment of its birth, space began to expand, and even now that expansion continues, faster and faster. This doesn't happen because galaxies fly away from one another like scattered debris, but because the very fabric of space between them is stretching, as though the cosmos were a vast sheet of cloth being slowly pulled taut. The galaxies, like tiny points embroidered onto that cloth, are carried along by the expansion, drifting apart in the most natural way. This phenomenon is explained by a concept called dark energy, a mysterious form of energy that makes up most of the universe, yet cannot be seen or touched, only inferred through the effect it has on space's expansion. Dark energy makes no sound and casts no light, but it plays a decisive role in the universe's long-term fate. It is like a gentle but persistent force, nudging everything farther apart, making the distances between galaxies grow ever larger. If you imagine watching the night sky over the course of billions of years, this change would appear slow but steady. Distant galaxies would fade, their light stretched into red trails before dissolving into darkness. Familiar constellations would lose their shapes as their stars drift farther from one another. The sky, once filled with glowing bands and star clouds, would gradually thin out, becoming as empty as the vast voids scattered through the universe. One day, in a future incredibly distant from now, when the universe has expanded to its extreme, the night sky might hold only our own galaxy, or whatever remains of it, floating in a dense, velvety darkness. Other galaxies, once glittering neighbors in the early cosmos, will have slipped beyond sight, past the horizon where their light can no longer reach Earth. The universe then will resemble a colossal Boötes void, not in just one region, but nearly everywhere. Though this vision appears lonely, it is not frightening. It is simply the universe's natural rhythm, unfolding so slowly that no single lifetime could ever feel it. This expansion is like the universe's background music, a soft, steady breath it has been taking for billions of years. Every galaxy, every star, every empty space drifts along with this flow, like leaves gliding across a calm surface of water. Thinking about that distant future, you can picture the universe as a vast ocean of night, always widening, letting everything drift a little farther apart, not out of separation, but because space itself is stretching. These shifts happen gently, as softly as a breeze rippling across quiet water before fading away. Everything remains serene, even as the grandest changes take place. Remembering the voids we've passed through, the universe's future resembles an ever-widening sequence of such emptiness, spreading from one region to another. Galaxies will become rarer, their light dimmer, and silence will grow into the defining quality of space. Yet within that stillness lies a somber beauty, like a symphony ending on long, lingering notes. The expansion of the universe also reminds us of our smallness within the cosmic flow. Earth is only a speck within a galaxy, and that galaxy is just one among billions. Everything we consider enormous becomes small when placed against the universe's tapestry. But that smallness is not unsettling. It is calming. Understanding the vastness of the universe is a way of understanding that life does not need to be heavy. Everything has its time, moving in its own natural rhythm, just as the universe has done for billions of years. This expansion is not only a physical measurement, it is the slow breathing of all space. Each galaxy drifting farther apart is like a sound fading in a long, gentle composition. If we listen with the mind, we can feel the expansion like a soft wave, carrying everything outward without harming anything. It simply opens up, like a door easing open into a larger room. The final outcome of this expansion may be a universe cold, dark, and silent. But within that silence lies a quiet beauty, like the long dusk sliding into night, where everything fades gently into shadow. The universe does not extinguish itself suddenly. It dims slowly, thoughtfully, like a candle burning down to its last drop of wax, softening its glow. And when we imagine that distant scene, we can feel a deep layer of peace, as though the universe were lifting a hand to gently shield the last bit of light, preparing itself for a long slumber. In that tranquil moment, the journey carries us toward the final chapters, where the story no longer speaks of expansion, but of the ultimate ending, a long night the universe will enter after its nearly eternal voyage of light and motion. As we imagine the universe continuing to expand into immeasurable distances, where galaxies drift away from one another like tiny boats fading on an endless night sea, a gentle thought slips by like a thin passing cloud, that every motion, no matter how vast, eventually finds its final shore. And from that idea of endless separation, the journey opens into a new chapter, guiding us toward the quietest vision of the cosmos, an ending not marked by noise, but by absolute stillness. In a future so distant it lies far beyond any human measure of time, the universe will enter a stage known as heat death. It is not an explosion or a violent collapse, but a slow, soft unwinding, like the final breath of a being that has lived far too long. The last stars will go dark, each brilliant flame fading like the final streaks of light across the sky. No new stars will form. No swirling clouds of gas will gather to spark the next generation. The universe enters an era in which energy becomes too thinly spread for any transformation to occur at all. Stars that once shone fiercely will gently cool. Some will become white dwarfs, and over unthinkable spans of time, cool further into black dwarfs, cold, dark spheres of silent matter. The more massive stars that exploded long ago will leave behind neutron stars, or in more extreme cases, black holes. Deep into the universe's far future, these remnants will persist, drifting through space like quiet mountain stones laid into a timeless night. But even black holes, those seemingly immortal objects of imagination, do not last forever. Over time, they evaporate ever so slowly through Hawking radiation. A supermassive black hole may require trillions upon trillions of years to vanish entirely, yet eventually it too will fade until only the faintest whisper of space remains, and then even that whisper dissolves. When black holes disappear, when black dwarfs cool beyond recognition, when no source of energy remains to stir space in even the smallest way, the universe enters a nearly motionless state. Temperatures fall to the edge of absolute zero. Fundamental particles, electrons, protons, neutrinos, continue to exist, but without enough energy to assemble themselves into anything new. Everything becomes thinner, lighter, so still that time itself has nothing left to mark. Imagine a universe where there is no light left to see, no galaxies to admire, no supernovae to ignite the darkness. Space becomes an infinite black ocean, not because darkness has grown, but because nothing remains to shine. And yet, rather than fear, this vision carries a strange and quiet beauty, a beauty born from absolute peace, from a silence nothing can disturb. When all motion has ceased, when every physical process has reached equilibrium, the universe feels as though it has fallen into a deep sleep. A sleep without dreams, without movement, but filled with the serene completeness of something finally at rest. For just as every story needs its final chapter, the universe, after an inconceivable journey, arrives at its own ending. Not tragic, but restful. Look back at the path the universe has taken. From the Big Bang, the most powerful opening note imaginable, to the formation of galaxies, the lighting of stars, the birth of planets. From brilliant supernova forging heavy elements to the creation of rocky worlds, gas giants, icy spheres, and extraordinary landscapes that human imagination has only begun to glimpse. From the emergence of life on a small blue planet called Earth to the moment humanity looked upward and began asking questions about the cosmos. All those movements, all those wonders, all those layers of history were notes in a cosmic symphony billions of years in the making. And when every note has sounded its last and gently fades, when the symphony reaches its softest ending, the universe does not collapse in chaos. It simply slips into darkness with grace, like a candle that has burned through its wax, leaving only a thin curl of smoke dissolving into the air. Imagine this final scene as a vast painting. No violent strokes, no lines tearing across the sky, no urgency. Only layers of darkness blending slowly, evenly, like a sunset that never ends, stretching into forever. Such stillness may make the human mind feel adrift, yet it also offers a strange comfort. For if the universe, with all its immensity, can enter a peaceful sleep, then the rest of us, small as we are, can accept our own rest just as naturally. In this imagined last moment, there is no longer a distinction between light and shadow, heat and cold, energy and silence. Everything merges into a single, lingering note until it becomes indistinguishable from perfect quiet. And within that quiet, a new feeling appears, the sense that the universe has completed its journey. From that moment on, knowledge no longer leads the way. Physics, equations, models, all of it can be gently set aside. In their place, emotion becomes the guide. Emotion for a universe that once burned bright, once pulsed with change, once held countless wonders. Emotion for the smallness of human life when placed before something so vast. Emotion for the beauty of the finite set within the infinite. And from this moment, the journey turns inward, to you. For as the universe drifts into its long sleep, you too are invited into your own. A rest not of ending, but of renewal. A sleep that lets the mind float into ease, like star remnants drifting softly through endless dark. As thoughts settle, as the last stars fade into silence, allow yourself to feel that rest is a natural part of every cycle. There is nothing to hurry, nothing to resist. The universe has rested, and you deserve that rest too. As the image of a universe drifting into the long sleep of heat death still echoes softly in the mind, a gentle space opens, like an invitation to step into its final reflective chapter. And in that moment, when the cosmos has settled into perfect stillness, the listener's journey quietly turns back toward humanity itself, the way a long road eventually leads home. We have traveled through an expanse so vast that every ordinary measure feels small. It was not just a flight of imagination through the stars, but a slow walk across the entire history of the universe. From the age when it blazed with supernovae, to the distant future when it fades into the final breath of cold. Every stop along the way held an image, a feeling, a distinct layer of meaning. And now, nearing the end, the journey seems to slow and soften, letting the listener take in the whole picture once more, wrapped in quiet peace. Imagine opening a thick book, and as you reach the final page, all the pages before rise in memory like a single flowing recollection. The first chapter carried us to worlds of fire, planets with surfaces that melt and swirl like oceans of lava, glowing red under the fierce heat of nearby stars. These worlds were never meant for the kind of life we know, but they reveal the harsh diversity of the cosmos. The next chapter took us to icy planets, where light is rare and temperatures fall so low that time itself feels frozen. They stand as the opposite extreme of the hot worlds, but together they show that existence in the universe is never just one thing. Then came the wandering planets, lonely spheres of rock, gas, or ice adrift in starless darkness. The silence around them stretches like an infinite room, offering a strange, haunting kind of solitude. When we lifted our gaze to the dual suns of special worlds like Kepler 16b, we found a different kind of beauty. Not violent, not frozen, but dreamy and uncanny. And upon meeting the pitch-black planet TRES-2b, we entered the silence of a world that swallows light, where darkness is so deep it feels almost solid. From there, the journey carried us to the stars themselves. Each star was like a grand chapter in the story. Stephenson 2/18, so vast it feels ready to drape across the sky. We are 102, hot enough to blast away anything that dares come near. R136A1, shining brighter than imagination usually allows. And yet, despite their immensity or ferocity, all of them obey a simple truth. Stars live and die by the same natural cycle as everything else in the universe. With neutron stars and magnetars, we witnessed matter compressed to its most extreme, where a single spoonful would weigh more than a mountain range. With black holes, we encountered the outermost boundary of space-time, where light bends and the idea of motion loses meaning. With quasars, we saw the brightest beacons in the cosmos, energy flaring like a cosmic bell ringing from galaxies unimaginably far away. And after all that, brilliance, we stepped into the tranquil darkness of the Boötes void, a stretch of emptiness so wide that everything we know seems to shrink within it. It isn't frightening. It simply shows that the universe holds spaces that are not meant to be filled. Then we arrived at the expansion of the cosmos itself, watching galaxies drift apart, hinting that the far future will be quieter than anything we can imagine. After passing through all these wonders, Chapter 16 led us to the final vision, the heat death of the universe. But instead of tragedy, it revealed a lullaby whispered by space, stars dimming gently, galaxies dissolving into darkness, energy fading until the cosmos enters an endless rest. And from that distant ending, this chapter opens like a doorway leading us back toward Earth, back toward ourselves, back toward the human need for sleep. For amid all those extremes, fire, ice, dazzling light, infinite shadow, Earth becomes something extraordinary. Not too close to its star, not too far, not too large, not too small, not too harsh. A tender balance nestled in the Goldilocks zone. It is this quiet equilibrium that makes Earth a home for life, a place where humanity can look out at the endless universe without losing its way. Seen from afar, the cosmic journey resembles a human day. There are bright moments, dark moments, powerful moments, weary ones. And just as every star eventually fades, every person needs rest. Not out of weakness, but because it is part of the rhythm of being alive. Sleep is not an ending. It is where beginnings gather their strength. Let that thought drift through your mind, light as moonlight falling on a calm ocean. Let every image of the universe, molten worlds, colossal stars, infinite voids, soften into a single, gentle picture. You do not need to hold them all. You do not need to analyze them. Simply let them become faint glimmers in memory, like distant stars scattered across the night. Looking back, you may realize that the beauty of the universe lies not in its scale or power, but in the feeling it leaves behind. A sense that, within the vastness, humanity still has a place, small but undeniably meaningful. That instead of being swallowed by infinity, our existence is made more precious because of it. The more we gaze into the cosmic expanse, the more clearly we see the worth of this small home. And as that reflection settles toward its end, the narration softens even further, like a thin blanket draping itself over every thought. The cosmic journey does not conclude with thunder, but with a whisper, a reminder that all the enormity out there ultimately guides us toward one simple thing: our own rest. So before stepping into the final chapter, where a goodnight wish falls like starlight onto a quiet lake, let your mind slow down. Let the feeling of your smallness become comforting, not frightening. Let Earth, the warm planet in a cold universe, become the place where you can lay your head, while distant stars watch over you like gentle companions standing guard through the night. And in that slower rhythm, the journey glides into its last part, where the universe offers the listener a lullaby drifting across the galaxies, soft as a breath, pure as the first light of dawn, closing the story in perfect peace. When the journey of looking back across the entire universe finally closes in the tenderness of its last reflections, a very soft silence begins to spread, like a thin veil of mist settling gently over the mind. And within that silence, the story opens its final door, guiding you into a space where only pure relaxation remains, where all knowledge has quietly dissolved into feeling, and every feeling becomes the slow, steady breath of the night. Let your mind settle for a moment, as if your thoughts have traveled a very long way and now wish to sit at the edge of the cosmos to rest. No more molten planets, no more frozen worlds, no more giant stars or lightless abysses of deep space. All of those images are still there, but they now rest behind you, fading into soft, distant specks in memory. In this moment, the most important thing is no longer to keep exploring, but simply to allow yourself to unwind, lightly, gently, as if drifting weightlessly through a quiet field of stars. Imagine the space unfolding around you, a place without gravity, without anything tugging at you, without any tension asking to be held. Only the sensation of floating, weightless, in a velvet dark expanse where thousands of stars shimmer across the sky like grains of silver scattered on an endless night. These stars are not here to overwhelm you. They're here to remind you that even in your smallness, you belong to this universe in a way that is beautifully natural. Now close your eyes in your mind's eye. No effort needed. Just let the door before you close slowly, carrying away the images of the long day. Let your breath move in a little deeper, and flow out a little softer. Each breath is like a tiny spiral of nebulae unfurling in the dark. You don't need to direct anything. Your breath will find its own rhythm. Now imagine your body growing lighter, bit by bit, as if each fragment of energy is gently releasing the tension that clung to you throughout the day. Layer by layer, the tiredness in your shoulders, your back, your chest, your mind, all of it slides off and dissolves into the peaceful space around you. No resistance needed. Just let it fall away. The night sky is wide enough to hold everything. Picture yourself drifting softly through a sparse field of stars. They glow with the tenderness of candlelight. Never glaring, never fierce, just quietly shimmering like the universe's own breath. You're not soaring, not falling, not being pulled. You are simply drifting, pure stillness, pure surrender, pure peace. As if the universe has placed you upon a gentle stream of light, carrying you through one last soft passage before sleep. Above you, the sky stretches without end. It no longer asks you to understand black holes or galaxies or immense cosmic motions. It asks only for you to see something simple. In all this vastness, you are not alone. Your presence, small as it may be, is still part of the universe's intricate design. No star is like another. No planet mirrors another. And there is no one else like you. You carry a light of your own, even on days you don't notice it. And notice how, as you drift among the stars, the space around you becomes profoundly calm. Not calm as in empty, but calm as in complete. Everything is exactly where it belongs. Distant nebulae curling softly in the void, icy worlds resting under violet frost, tiny dwarf stars asleep in the dark, entire galaxies reduced to thin streaks of pale light. All of them resting after their long, ancient journeys. And you too are allowed to rest, just as they do, without needing any reason at all. Feel your breathing as the universe is breathing. Each inhale is starlight, traveling across the dark. Each exhale is worn-out residue carried gently away by cosmic winds. You don't have to hold on to anything. This space is large enough for all of it, and kind enough to make everything feel light. If you listen closely, you'll notice that this silence isn't empty at all. It carries a subtle rhythm, the faint pulse of some distant, enormous heart. The universe is still alive, still breathing, even without urgency. And that life reaches you, reminding you that rest is also a kind of motion, a motion inward, toward your own center. Let the image of that shimmering night sky spread over you like a dome of soft light. Let the stars become quiet guardians, keeping you safe in the dark. There is nothing you need to worry about, nothing more to think through. Only one task remains, allowing yourself to sink gently into sleep's softness. And as that softness begins to settle deeper into your mind, your eyelids, your breath, let the lullaby of the universe whisper a blessing meant just for you. You are made of stardust. You are built from atoms that once burned in ancient suns. The history of light lives inside you, and because of that, you deserve rest. You deserve ease. You deserve to be restored for tomorrow. Sleep well, like a planet spinning slowly beneath the arms of its parent star. Sleep well, like a quiet nebula waiting for the day it will shine. Sleep well, like the final glimmer of light before it melts into the night. Let sleep pull you downward, gently, slowly, surely. The night sky is still there, and will be there all night, holding you in complete peace. You don't need to carry anything from the day. You don't need to prepare for tomorrow. Let tonight belong entirely to rest. Sleep well, little traveler of the universe. When you wake, you will shine again in your own way, soft as starlight, steady as an orbit, and beautiful as everything you have just journeyed through.